Hello, 6-7s. This is Mrs. Morrissey here. So I'm trying to show you a very untechy lesson tonight that you'll be doing tomorrow afternoon. So bear with me. I apologize. This is something that I'm trying to do because I really want to sort of get in there so you can see it better. And this is the only way I could come up with at this point. So the first thing we're going to look at is moving points from one spot to another. And I call it swoopies to count. And for me, you know me well enough by now, that a swoopy is one of these little whoop, swoop, swoops that help us count when we go from one spot to another. So here I have point A, and I'm moving that to point B. And I want to determine how far did I go. So I'm going to start on my point. I don't count the one I'm starting on, but when I make my swoopy, that's going to count as 1. And I'm going to keep swoopying along until I get to B. So that was 1, 2, 3, 4, 5, 6, 7. So we actually moved 7 to the right. The same thing applies if I'm working down. I'm starting at point A and I want to move to point B. So I'm actually going to start on point A. I always put my pencil on point A and I swoop 1, 2, 3, 4. And I've moved my point down 4. I know this seems like really basic, but sometimes we forget. We sort of start counting on A as 1 and then moving, but we don't start counting at 1. We do our swoop and do a 1. Swoop 2, swoop 3, swoop 4. I think you got that part. Okay, so the next thing we're going to do is we're going to move certain points on our coordinate planes. We're going to move certain points in certain directions. Okay, we're going to move them along the x-axis, or we're going to move them along the y-axis. So the first thing we have is point A. And if you look at point A, we can see that point A is at -3, 2. And I've written it down here is A equals -3, 2. I want to move that point 4 to the right. I want to move that point 4 to the right. So I'm going to put my pencil on my point and I'm going to move to the right, which is this direction. I'm going to move to the right 4 swoopies. 1, 2, 3, 4. And I'm going to put a new dot. Now you notice that this was labeled A. When I make a new dot based on my movements, this is now called an image. And when I name an image, I am naming it A1 because that means it is the first image off of A. If I was to move this dot again somewhere else, I would call it A2 because it is the second image off of A. So you notice that this is A and this is A1 because this is an image. And we need to make that distinction. It would be very confusing to map makers and cartographers and mathematicians if both of the points were labeled A. So this is our original point with no little number on superscript. And this is our image, A1. Now I need to figure out after I've moved 4 to the right, what are the new coordinates for point A? So I go along my x-axis first. So I step into the elevator at 1 and I go up 2 floors to 2. So I'm going to write down here, I'm going to write A1, because that's my image, equals 1, 2. And that's my new coordinates. Now you'll notice that this totally makes sense because if we go back up to here, we have moved across the x-axis, but we haven't moved up or down the y-axis. So when I look back here, I have moved on my x-axis. I have moved on my x-axis, but I haven't moved on my y-axis. So this is showing me this very nicely as well. Okay, let's look at my next example. My next example is letter B. For letter B, I am along the x-axis at -6, and along the y-axis at -4. So you can see that my original coordinates are -6, comma, -4. I want to move this up 5 spaces. I want to move up 5. So I'm going to start at my original coordinate, put my pencil on my original point, and I want to swoopy up 5. 1, 2, 3, 4, 5. And I'm going to put my new point. And I'm going to label this right away B1, because this was my original, and this is now my image. Now I need to look at my new coordinates for this point. This point along the x-axis, along the floor, is -6. Then up the wall is +1. So I'm going to go down here and I'm going to record my image of B is at -6, comma 1. And again, this totally makes sense because along the x-axis, I didn't move. I'm still at my -6 along the x-axis, but I moved up the y-axis. So when I look back at my coordinates, my x-axis are the same, but my y-axes have now changed to reflect my movement up. All right? I think we got that. So we can move in one direction, but we also know that points will sometimes move let's go back a minute. Here's a fancy way to show our movement as well. So instead of just saying up or down, I've actually created, let's go to this one first. I've actually created a bit of an algebraic expression here. Algebra is when I have unknown quantities and numbers, letters and numbers mixed together to solve my problem. So my original dot is at 2, 1. And here it shows it as 2, 1. Now this one is asking me for my image of E, my E1, my image of E to equal x, y, x, comma, y minus 4. So that tells me my x isn't going to change. So it's going to stay along the 2, but it's going to tell me now that my y is going to be 4 less, or -4. So let's go back up to our original dot. I'm going to stay on my 2x, on my x-axis at 2, but I'm going to now go down 4. A negative is like going down, so I'm going to go down 4. 1, 2, 3, 4. And I'm going to put my new dot, and I'm going to label it E1, because it was asking me to create an image of E. So there's E1. So now if I look back at here, my x hasn't changed, but my y should be 4 less. So let's look at my coordinate points up here. My coordinate points are along the floor 2 and down to -3. So let's record that down here. 2, comma, -3. All right, so if we look at this, my x's are the same. They haven't changed. We're good. My x's are the same, and that's telling me here that my x is no different. This part of the equation is telling me that it's y minus 4. Well, if I start at 1 and I subtract 4 from our lessons last week, that 1 take away 4 is going to get me -3. So I know I've hit the right spot. Our use of integers comes in very handy right here. Let's do one more example. Here is f. This is f, and this original point at f is along the x-axis, -5, and down to -3. And you can see right here, my original coordinates are -5, comma, -3. This is in quadrant 3 because they're two negatives. So let's go back to here. I have a -5, -3. Now, according to this, my image, f1, needs to be at x plus 2, comma, y. So that's telling me that my y is going to stay the same. So my y is going to stay -3. My x has to increase by 2. So let's go back to my original space here. Here's my f. I want to keep it on the -3 because it's telling me that my y stayed the same. See, my y stayed the same. My x went +2. So plus means going to the right. Plus means getting bigger. So if I take -5 and I add 2, 1 swoopy, 2 swoopy, and label it my image, I have a new point. And let's take a look at it. Oh, let's take a look at our new coordinates. Our new coordinates along the floor is -3, and then down to -3. So let's write that down here. Is -3, comma, -3. And if we look back at our equation, we can see that y was supposed to stay the same, and it did, yippee yes, and our x was +2. So think about our integers from last week. -5 plus 2 is going to get me -3. So look at that, I got my new coordinates. There's my F1 image at -3, 3, and I follow this algebraic expression to figure out where my coordinates were. Okay. Sometimes they're not so spiffy and they just give us these. Up 3, left 7. So we can very easily do that. So look at our A. Here's our original A coordinate. And this is telling me that our image 1 needs to go up 3 and left 7. So I'm going to go up to here, and I'm going to go with the right colored marker, up 3, 1, 2, 3, and left that way 7. 1, 2, 3, 4, 5, 6, 7. Now you don't need to put the swoopies up and around, but I find, especially when you're working in pencil, they're very helpful. It keeps you in track. It keeps you online, and they're easy to count. And if I need to, absolutely, I could erase them, but why would I? Because they're actually showing me my work. So now we have gone up 3, 1, 2, 3, paused there briefly. I could put a dot there, but that might be confusing. So I'm just kind of holding still. And now I'm going to go left 7. 1, 2, 3, 4, 5, 6, 7. And there's my new point. And I've labeled it A1 because it is an image of A. Now let's look at the new coordinates for A1, for our image. Along the X, I go into the elevator at -3, and I go up 1 floor to 1. So let's come down here. My new image should be at -3, comma, 1. All right, that looks good. All right, let's try one more for B. I kind of went over my B mark there, but we can see it. My B originally starts at 1, 1. There it is at 1, 1. My instructions are telling me to make an image of B1 at right 5, down 5. So I'm going to go over to here. I'm going to go right 5, 1, 2, 3, 4, 5, and down 5. 1, 2, 3, 4, 5. And I'm going to make my new point, and I'm going to label it B1 because it is my image. All right, and my new coordinates for this image is I'm going across the floor to 6, and I'm going down to -4. So let's write that down here. 6, comma, -4. And that sort of makes sense if we think about our algebra that we did earlier. If we started at 1 and are being asked to go right 5, right is a positive movement. So 1 plus 5 is 6. If I look at my next number on the y coordinates, we started at 1 and I went down 5. Down is a negative movement. So 1 minus 5 gets me to -4. So I know I've done a good job there. Flip the page. Okay, We can do the same thing now with shapes. So here we have a lovely right angle triangle. I wish I had a ruler with me, but I did not. So it's a decent right angle shape, and I have labeled it A, B, C. Vertex A, vertex B, vertex C. Now, according to my instructions, I want to go 5 left and 2 down. And if I want to look at the algebra of it, I want to go x minus 5, because left is a negative movement, x minus 5, and 2 down. And down is a negative movement, so I want to go y minus 2. So let's go back up to our points. We're going to start with point A. So with point A, it is currently at 2, 2. So I'm going to record that right in this space over here. I'm going to record that as 2, 2. Get it out of the way so I don't forget. Okay? Now, I want to move it 5 to the left and 2 down, or x minus 5, y minus 2. So I'm going to start on my point, put my pencil on my point. I'm going to swoopy 5 to the left, 1, 2, 3, 4, 5, and I want to swoopy 2 down, 1, 2. And there is my new point. And I'm going to label it right away as image 1, because I'm moving 3 points. And I want to make sure that that same point is labeled correctly. Now, my new coordinates for this are -3 along the floor, and I don't actually move up or down, so it's actually -3, 0. So I'm going to write here beside it, A1 equals -3, 0. Brackets. Now, I have 2 strategies that we can do for our shapes. Technically, if I know that this is my image of A, if I look up here for B, point B is 1, 2, 3 up. So I could come to my image A and simply go 1, 2, 3 up. If I was confident that A was in the right spot, I could simply use this as my guide and go up 3, and then use my new image as a guide and go up 3, and this would be B1. Then if we look back at C, C is 1, 2 swoopies to the right from A. So my C1 is going to be 2 swoopies to the right from A1. And I could put it there. And then I can use my ruler and I could connect my dots. And I now have a translated image from here to here. Now let's go and quickly record my coordinates for B and C. So my coordinates for B are 2 along the X and 5 along the Y. So let's write 2, 5. And for C, let's get the original out of the way, is 4, 2. So let's go over here and write 4, 2. Now let's go up to our image. Our image of B1 is -3, 3. So let's write that down here, -3, 3. And my image of C is right here, which is -1, and we don't go up or down, so it's -1, 0. So let's go here, -1, 0. Now, if we look back at our algebra here, x minus 5, y minus 2. Let's look at our B coordinates. Our B coordinates were originally 2, 5. My x told me to do x minus 5. So if I look up here, I actually see 2, if I write this down here, 2 minus 5, and on my number line, I'm going to actually get an answer of -3. And lo and behold, there is my x-coordinate at -3. My original coordinate for B on the y-axis was 2, and according to our algebra down here, it says y minus 2. So if I take my 5 and I subtract 2, let's write that down here. 5 subtract 2, I get 3. And lo and behold, there's our number there. So actually, even though this is a very safe and stable way to make our translations, if we have our spiffy algebra down here, we can actually make the translations on paper without having to make our movements here. As long as we remember that left and down are negative and right and up are positive. All right, one more question, I believe. There it is. One more question. All right, I have a lovely looking rectangle here. I have my points labeled A, B, C, D, and I have my algebraic formula here of x plus 5, y minus 3. All right, so if we're going to take a look at this, here's my A point, my original A point. Let's write that down here. My A point is originally, sorry for the crazy movements here, my original point is -4 along the x-axis and -1 down the y. So let's write -4, -1. All right. Now this tells us I need to go x plus 5 and y minus 3. Plus 5 is a positive number, so I'm going to be moving to the right. And y minus 3, y is a minus 3 is a negative number, so I'm going to be moving down. So it's like the same thing as saying right 5 down 3. I hope this doesn't interfere with my new points. Let's see what happens. So I'm going to start with my A point, and I'm going to move A5 to the right and down 3. So I'm going to use my swoopies because that's what I like best. 1, 2, 3, 4, 5. And down 3. 1, 2, 3. Oh, we're just going to be good. And there's my new point. And I'm going to label that new point right away so I don't forget. It is A1 because it is an image of A. All right? And now what are my new coordinates for my A1? My new coordinates are 1 across the x-axis and -4 along the y. So let's write A1 equals 1, -4. Now if we go back to here and I see my x plus 5, let me see if I can zoom out a bit so I can point to everything. Okay, so here's my x plus 5. If I'm at -4, let's write this down here. Think about our integers from last week. If I'm at -4 and I add 5, -4 plus 5 on my number line will actually get me +1, which is what we got right over here. Now, my y is y minus 3. So if I look at my y over here as -1, let's write this down here. -1 minus 3. So that's actually getting more negative. So -1 minus 3 more negatives actually gets me -4. And lo and behold, here's what I've got right here. Close those coordinate points. So once I've confirmed that A is in a good spot, then I can simply translate all of my points. I can move my points, slide my points. Now, A is, from A to D, is 1, 2 to the right. So from A1 to D1, it is 1, 2 to the right. And I'm going to label that D1. Now, from D to C is 1, 2, 3 up. So from D1 to C1 is 1, 2, 3 up. And I'm going to label that C1. And from C to B is 1, 2 to the left. So from C1 to B1 is 1, 2 to the left. And then I can use my ruler and I can redraw my shape. And so now we have moved our rectangle, A, B, C, D. We have moved it x plus 5, y minus 3, and we now have it over here at A1, B1, C1, D1, and we have our new coordinates. So this, grade 6/7s, is a really quick way about translating points, lines, and shapes on a coordinate grid. I hope this helps. Watch this as you need it and do the work that is assigned. Thanks very much for listening. Hope it wasn't too scary a way to learn. Bye. Hello.